Hello everyone. Today we are going to discuss the logic circuits as a combinational circuit. This is our second part. In this part we are going to discuss the multiplexer, that is MUX, that is MUX. So here we are going to discuss introduction of multiplexer and multiplexer 4x1. By learning this lesson, you will be able to know what is the block diagram and circuit diagram of multiplexer, types of multiplexer and use of multiplexer, and finally suitable and output expression of 4x1 multiplexer. So let's start. So digital circuits are two types. One is combinational circuits and another is sequential circuits. These combinational circuits which do not having the memory, so this does not have the memory, and the sequential circuit which have the memory. So here this combinational circuit which do not having the memory means that the whatever the output of combinational circuit, that is totally depends on instantaneous or present given input, but not a past given input as well as past given output, because it do not having the memory. So in sequential circuit, the sequential circuits which have the memory, and that's why the whatever the output of this sequential circuits, that totally depends on present input as well as past given input as well as output. These are the example of sequential circuits and these are the example of combinational circuits. So here in this lesson we are going to discuss the multiplexer. So multiplexer, that is MUX. Introduction. The digital data is available in many lines, that is number of lines, in many electronic systems. So here in digital data is available in many lines, number of lines. So that's number of lines is converted into a single line. For that purpose we require a multiplexer. So it is required to convert or route this number of data lines into a single line. For that purpose we require a multiplexer. Due to this reason, so here what will happen, we have using the several number of input and that is converted into a single output. For that purpose we use the multiplexer, and due to the using of multiplexer we reduce the number of wires, cost of circuit, and also the complexity of the circuit. So the multiplexer is the important part of digital circuit in microcontroller and microprocessor. Multiplexer means many into one. So we can say that many means number of several input data lines which will convert it into a single, only one output, that is single output. So multiplexer is the combinational circuit which do not having the memory, which select any one of the several data inputs and route into a single output. So many into one. So this is called as the multiplexer. So types of the multiplexer. There are several types of the multiplexer, that is 2x1, 4x1, 8x1, 16x1 and 32x1. So here we want to discuss the n by 1. So n stand for number of data inputs and only one outputs. So here 2 is the 2 inputs and 1 output. So here m is equal to 1. So what is the m and what is the n? So where n is the several input data lines and m is the select or control signal. So how to calculate the m? That is the select. So this is the formula. By using this formula we can easily calculate the number of select lines. Here n is the number of inputs, that is several input data lines, and m is the select. So by using this we can easily calculate the number of select. Suppose for example we have considered 2x1 multiplexer. In 2x1 multiplexer, 2 is the input, 2 is input data line and 1 is the output. So here for this purpose, so n is equal to 2, so n is equal to 2 means 2 to the power 1, that is equal to 2, that's why m is equal to 1. So here in this 2 by 1 multiplexer we need only one select. So by using this formula we can easily calculate how to calculate the one, that is the select. Suppose we have taken the another multiplexer, that is the 4 by 1. So how to calculate select m is equal to 2? So here n is equal to 4 means number of input data lines is 4. So here is equal to 4. So that's why 2 to the power 2, that is equal to 4. So that's why m is equal to 2. So in this way we have calculate how to take the select for 4 by 1 multiplexer. Similarly, if n is equal to 8 means input combination is 8 and 2 to the power 3, that is equal to 8. So m is equal to 3 and so on. In this way we will easily calculate select is m is equal to 3 for 8 by 1 multiplexer, and similarly select is 4 by 16 by 1 multiplexer, and similarly m is equal to 5 for 32 by 1 multiplexer. So block diagram of n by 1 multiplexer as shown in figure A. In multiplexer select, the use of select is used to control a particular input data lines for a certain output. For example, this is the equivalent circuit. So this n by 1 multiplexer, here these are the inputs, this is the one output, and this is the m select lines. So m select lines which control the signal, which control the particular input data line for certain output. So this is the enable is also the input, but this enable is always 1. So this is the equivalent circuit. In this equivalent circuit, here inside it we have showing the switch. So switch is put in any point by using the select. So that is the use of select, to select the particular input signal, and that will give to the output, and enable is always 1. So now we are going to discuss the 4 by 1 multiplexer. So 4 by 1 multiplexer means that which having the 4 input and only 1 output. So multiplexer has the 4 data input lines and only 1 output. So here we are using the 2 selects, and that how to calculate the select, that is m is equal to 2, already we have discussed in last slide. So 2 selects S0 and S1 lines are required to control a 4 input data lines as shown in block diagram this B. So here we are using the 2 selects, m is equal to 2, and this is our 4 data input lines, and this is only 1 output lines. This enable, that is equal to 1, this is always 1. So the truth table of 4 by 1 multiplexer is as, and the equation regarding this we have taken this. So finally we will get this equation. So how we will get this equation? Suppose here we are using the 4 number of combination is 4 input data lines. So this is the 4 possible combination. Suppose S1, S0 is the select lines, and this is the Y is the output. So for example, first combination 0 0. Suppose S1 we have take 0, S0 is also take a 0. So at that time we want to consider a D0. So D0 is activated and it will give the output. So second combination is 0 1. At that time D1 is activated. For 1 0 D2 is activated, and 1 1 D3 is activated. So here just we want to how to memorize this output. So just you want to consider 0, you consider as a S1 bar. Here is also 0, so that is the S0 bar. Here is the 0, so that is the S1 bar. Here is the 1, so that's why we want to consider S0, only S0, and D1 is as it is. Here is also D0 as it is. So 1, that is the S1, S0 bar, that is D2. So here we will get in this way. Similarly 1 1, that is the S1, S0 and D3. So in this way we will get. So this is our truth table of 4 by 1 multiplexer, and this all this we have added. So finally we will get this equation. So this equation also we will get by using the logical circuit of 4 by 1 multiplexer as shown in this figure C. So here we are using the 4 AND gate and 1 OR gate. So OR gate is used for the addition logic, and this AND gate is as like a multiplication logic. So already the AND gate which having the number of input and only one output. So in previous or last year we have studied that the logic gates, in that logic gate particularly we are using the 2 inputs and only one output, but logic gate which having the number of inputs and only one output. Similarly here we are using the 3 inputs and only one output. So here we have taken the 4 AND gate. So just you want to how to memorize this logical circuit, just you want to consider this S1, this is the S1 line, and this red line is the S1 bar line, this red line is the S0 line, and this red line is the S0 bar lines. So this first 0 0 0 0 means we want to consider S1 bar, S0 bar and D0 as it is. So for that purpose S1 bar, S0 bar, so we want to connect the input of AND gate to the S1 bar and another is the S0 bar, because here we have considered S1 bar, this line is the S1 bar and this is the S0 bar, this line is the S0 and this is the S1. Similarly for second AND gate S1 bar, S1 bar means we want to connect here because this is the S1 bar, and S0 means this one input of AND gate is connected to the S0 and D1 is as it is. Similarly third AND gate D2 is as it is, S1 S0 bar, S1 S0 bar D2. So that's why S1 is connected to here and D0 bar which is connected to the red line of this, and fourth AND gate D3 is as it is. So S1 S0, so that's why this one input of AND gate is connected to the S1 and one input is connected to the S0. So here we have take the NOT gate. So here NOT gate, suppose here NOT gate we have given 1, here we will get the 0 or vice versa. Similarly here also. So by using this equation we want to connect the input of AND gates. So already you have understand how to connect this input of AND gates to the S1 S0 S1 bar S0 bar. So finally this is the AND gate output we have connected to the OR gate and we will get the one output, and this is the combination of this plus this plus this plus this. Finally we will get the same equation according to gate from this truth table. Thank you. If you like this lesson, please like, comments and share with your friends, and don't forget to subscribe this channel. Thank you for watching this video till to end. Thank you very much.